Now let's talk about another reducing agent, which is NaBH4, which is known as sodium borohydride, or also known as SBH. It is also known as sodium tetrahydrido, its name borate 3. Its IUPAC name is this. How does it look like now? It look like Na plus, and we have B, H, 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 and H4 minus. Actually, if we compare it with LiAlH4, if we compare it with LiAlH4, lithium, Al, H, 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 and H minus. So LiAlH4 is actually a weak bond as compared to NaBH4 because of overlapping of boron and aluminum. Aluminum belongs to third period, so 3s 1p overlapping in the aluminum hydrogen, and in boron hydrogen it is 2s 1p overlapping, or 2p 1s. So 2p 1s is proper overlapping as compared to 3p 1s. So 3p 1s is poor overlapping, so it is a poorly overlapped. So that's why it loses H plus easily. So it is a strong reducing agent. So what we can understand by this, that NaBH4 is less reactive compared to LaH, because sodium borohydrate has more covalent character. Because bond energy of Hb is greater than HAl. So it can only react with, so only show reaction with, first is aldehyde, second is ketone, third is acid halide. So it only shows reaction with these three only, because these three has highest reactivity among all the C double bond O group type of compound. So let's say where we have a NaBH4. NaBH4 gives Na plus BH4 minus. Now BH4 minus gives BH3 plus H minus. So now let's talk about its reaction. First of all, let's say we have an aldehyde. So aldehyde reacts with RC double bond OH, reacts with first NaBH4, second H2O. So it will form RCOH, H and H. So how does it forms? And when it reacts with second NaBD4, second H2O, it will form RCOH, H and D. First it reacts NaBH4, so hydrogen will react this and it will form hydrogen. Now BaDH4 will give D minus will attack over here, this bond will go up, so it will form this. So that's how it similarly react with LiLH4, similarity, but it won't react on compound apart from aldehyde, ketone and acyl halide. Second, it will react with ketone. It's similarly way we have seen the video of LiLH4. Similarly, SBH reacts similar way, but only with 3 compounds. So it will form OH and H. Next we have acid halide. RC double bond O Cl react with SBH. Second it react with H plus and H2. So it will react RC double bond OH, which further gives RCH2 OH. It won't react with ester, anhydride, carboxylic acid. It doesn't react. So let's draw a chart of functional group. Here we have product. Here we have LiAnH4. Here we have NaBH4. So first of all, functional group, let's say we have an aldehyde. Second, we have a ketone. Third, we have R C double bond Cl. Fourth, fifth, we have anhydride. We're gonna look at more. First, look at this. The product form is RCH2OH, RCOH, H, R1 and here R2, RCH2OH, RCH2OH plus R1OH, and 2 moles of RCH2OH. So it will react with LiLH4. This all will react with LiLH4, but NaBH4 only these three reacts. This don't and this won't. If we write the more functional group, let's talk about sixth. Sixth we have cyanide. Seventh we have imine. Eighth we have isocyanide. Ninth we have amide. 10th we have acid. So the product of these are CH3, RCH2, NH2, RCH2OH. So will LiLH4 react? LiLH4 react, yes. It will give. But it won't react with, it won't convert with NaBH4. So now let's talk about NaBH4. Some questions. Let's say we have a compound. Let's react with LAH and let's react with SBH. In LAH it will react with both of the compound OH, H and H. But with SBH it will only react with outer side. So with SBH it will react with this and this. Let's look last problem. Second problem. We have this compound. First it will react with NaBH4. Then it will react with LiAlH4. NaBH4 it will form. With NaBH4 it will react with only acyl chloride part and will form OH and won't touch any anhydride part. But will LiLH4 it will form this compound.